In this problem, we're going to be looking at the limit as x goes to -2 of x plus 2 divided by x cubed plus 8. All right, let's get into it. The first thing that we're always going to do when we have a problem like this is try plugging in the number that we have for our limit. Where is x going? Plus 8. The problem with that, as we will find in a lot of our limit problems, is, and remember 2 cubed, when we have that negative sign, because there are 3 copies, we are going to get -8 plus 8, which is 0 over 0 for our limit, which is just going to be badness. So we're going to have to try a different way of evaluating it. Now, there are 2 different ways that we can actually go through this, and I'm going to give you 2 different tools. So tool 1 will be algebra. And this is probably the most common way to go about a problem like this, is to just use our algebraic prowess. But this is not going to be the best way. You'll have to keep listening to find out the easiest way. So solving this, what we need to do is notice that in our denominator we have an x cubed plus 8. So basically what we need to do is we need to take that x cubed plus 8 and rip it apart and pull out of it, factor out of it an x plus 2 so that we can cancel something on the top and the bottom of our fraction, which means we need to figure out how to get that out. And to do that, we are going to divide our fractions, our polynomials. So we are going to divide x plus 2 out of x cubed. And this is technically x cubed plus 8, but I'm going to rewrite it slightly different. When we do polynomial division, a lot of time it is useful to put in all the terms of our polynomial. So you'll notice here I added 0x squared and 0 times x. Those are going to be used as we divide out. Now, when we go through this, the first thing we're going to do is we're going to look at our first term of both the divisor and the dividend. We want to multiply to get those to match up. So we are going to multiply by x squared. X squared times x plus 2 is going to give us x cubed plus 2x squared. All right. Now I know it's been a long time since we've done long division, but we are using the same principles. It's just in a polynomial form, complicated as that is. We are going to subtract that from what we see above. So our x cubes are going to cancel. And we get 0x squared minus 2x squared. Don't forget that negative sign out front is technically going to be distributed underneath. Okay, and that actually, I will say, is a problem that often comes up. All right, is forgetting to distribute, that is. All right, so now we need x times what gives us -2x squared. Well, x times a -2x will give us -2x squared. So we multiply that -2x throughout what we see there. And I always like to put my parentheses in to remind myself that that negative sign pops all the way through. So we are actually adding 2x squared, which means these 2 terms are going to cancel out. And then we have a minus 4x, which gives us positive 4x plus 8. Last thing we're going to do is we want to see what do we multiply by x to get 4x. Well, that is going to be plus a positive 4. So that's going to give us 4x plus 8. Subtract that whole thing and we get 0. This part is lovely because what it tells us is that x cubed plus 8 can be rewritten as x plus 2 times x squared minus 2x plus 4. And if you think you'll never use this again after Calc 1, wait until you get to Calc 2. It will come up. Polynomial division will come up again. Okay, So let's actually rewrite, we're going to use that information. We're going to rewrite our limit. X goes to -2. And I'm not saying that to scare you about polynomial division. I'm just saying it's not a bad idea to remind yourself how to do it, because it's likely it'll come up again. All right, now we see an x2 on our numerator and denominator of our limit. We can cancel that out. We get the limit as x goes to -2 of 1 divided by x squared minus 2x plus 4. And now we can just plug in our -2, because at this point, the problem that existed, getting 0 over 0, has disappeared because we've been canceling out that x plus 2. So this gives us 1 over -2 squared, which is 4, plus -2 times -2, which is another 4, plus, so we get 1/12. All right, this was a lot of work, but there is an easier way to solve this limit, and a wonderful way. So the second way is we are going to use L'Hopital's rule, or as I like to call it, LHOP. So the LH for LHOP. There are only certain conditions under which you can use L'Hopital's rule. One of those conditions is that we get 0 divided by 0. So that condition has been met, which means we can use L'Hopital's rule. L'Hopital's rule says if we have a limit where when we plug in the number, we get 0 divided by 0, we can take the derivative of the numerator and the denominator, and we're going to take those derivatives separately, and this is going to give us the same limit. So we're going to start off with the derivative of the numerator. So basically that's d dx of x plus 2, which is going to give us a 1. All right, pop that in there. And then we do the derivative of the denominator, and we'll do that separately. So we're going to bring our power down, subtract 1 to get our new power, and constants will disappear. So 3x squared. And now notice, again, in one step, we've eliminated the issue that we had before, and we can just pop in our number there. So this gives us 1 divided by 3 times 4, which yet again, which is always good when you get the same number, is 1/12. So keep this in mind as a useful tool going forward. Thanks for listening.